There's that song. The one where the bridge hits and your spine tingles. Your eyes sting. The room briefly gets larger. You can't explain why. You've heard the song 100 times, and every time, it does the same thing. Why? What's happening in your brain when music gives you chills? The word for it is frisson. From the French, it means shiver. It's a psychogenic precursor to orgasm, in the dry clinical language of researchers who, presumably, were trying very hard not to blush. The body responds as if to something physically cold. Goosebumps. A shiver down the spine. A catch in the breath. Hair standing on end. But there's no cold. There's no threat. There's just music. So the body is responding to a meaning, not a temperature. Most people can feel frisson. Studies vary. Somewhere between 75 and 90% of adults report having experienced it. For some, it's a frequent occurrence. For others, only with a specific piece of music. A small group, perhaps 5%, feel it intensely and often. And there's another small group who almost never do. The capacity to feel chills from music is unevenly distributed. It's a personality trait as much as a sensory one. The neuroscience of frisson is, at this point, fairly well mapped. The key player is dopamine. In 2011, a team at McGill, Salimpur and Zald, put music lovers into a brain scanner and let them listen to their favorite songs. The ones that gave them chills. What they found was remarkable. Dopamine release in the caudate, a deep brain structure involved in reward, spiked in two distinct moments. The first spike came just before the emotional peak of the music. Anticipation. The second spike came at the peak itself. Resolution. Your brain was rewarding both the prediction and its fulfillment. Twice. This is where predictive processing comes in. Your brain is a prediction engine. Constantly building models of what's about to happen and checking them against the sensory input. Most of the time, you don't notice. But music, composed, structured music, is, by its very nature, an exercise in setting up and then breaking predictions. The composer gives you a pattern. Then, at exactly the right moment, the composer breaks it. A chord that isn't the one you expected. A vocal that lands a half beat late. A key change where there shouldn't be one. The gap between what your brain predicted and what it actually hears, that gap is the chill. And composers know this. There are certain harmonic moves that reliably trigger chills. The deceptive cadence, a V chord resolving not to I, as expected, but to 6. The minor 4 chord in a major key. The Picardy third, a major chord resolving at the end of a piece in minor. Modal mixture, borrowing chords from a parallel key. These moves aren't accidents. They've been refined over centuries because they reliably create the precise degree of surprise that the brain rewards. The chill isn't a mystery. It's a measurable response to a pattern that has been mathematically optimized to produce it. One of the things that makes music special is that it's nearly universal. Every documented human culture has music. Even the most isolated groups, the Piraha of the Amazon, the various First Nations communities of North America, have complex musical traditions. And while the specifics vary wildly, different scales, different rhythms, different instruments, the underlying pattern is the same. Music is structured. It has rules. It has moments of resolution and surprise. And it has, in nearly every culture, the capacity to move listeners to tears or chills or both. Whatever music is doing to your brain, it's doing something fundamental. There is, however, a darker side. Some people can't feel chills from music. They can hear it, appreciate it intellectually, even say they like it, but the shiver never comes. This is called musical anhedonia. And it's linked, often, to broader forms of emotional flattening. People with depression, with certain forms of autism, with Parkinson's disease, may experience music without the frisson. The chill isn't just a luxury. It's a sign that the reward system is firing properly. When it doesn't fire, that's information. Who's most likely to feel frisson intensely? The trait that predicts it, more than any other, is openness to experience. One of the big 5 personality traits. People high in openness are curious, imaginative, sensitive to aesthetics, drawn to novel experiences. They tend to feel frisson more often and more strongly. Introversion also correlates modestly. And musicians themselves, unsurprisingly, feel chills more than non-musicians. The capacity seems to be part temperament, part training. You're partly born with it. You're partly built into it. So when that song hits, that one song, the one that still gets you every time, what's happening is older than language. Your brain is being rewarded for anticipating the unexpected. A composer, maybe centuries ago, wrote a sequence of notes that reliably triggers the same dopamine response in your caudate that a lover's touch or a beautiful view might. And your brain, in its ancient, dopaminergic wisdom, marks the moment. You feel it as a chill. As awe. As a kind of love. It's one of the most human experiences